In this video, we're going to talk about the formulas for hyperbolas, and we're going to go over everything you need in order to actually do problems with hyperbolas. It's a lot, but once you get it, it's not that bad. So there are two main formulas. So these are the formulas for hyperbolas centered at the origin. So one, the first formula is this one, x squared over a squared minus y squared over b squared equals 1. And the second formula, I'll write it over here, is y squared over a squared minus x squared over b squared equals 1. And you can see the differences right away between these formulas. So in this formula here on the left, the x comes first. So I'm going to write that down. X comes first. And the way I memorize it is whenever the x comes first, this hyperbola opens left and right. So opens left and right. So if the x comes first, it opens left and right. Here, the y comes first, so I'll write that down. Y comes first. And if you thought it, you're probably right. It opens up and down. So opens up, down. Just a really nice way. So whenever you see the x coming first and there's a minus sign, you know it opens left and right. If the y comes first and there's a minus sign, you know it's a hyperbola, so it opens up and down. Or if it's a plus sign, it's an ellipse. In this, a and b are positive. Also, a and b can be the same here, right? In an ellipse, a and b are different. Here, a and b can actually be the same number. Okay, let's go ahead and graph these hyperbolas, and then we'll give some other things names. So to graph this one, the center here is 0, 0 in this case. So here's the y-axis, and here's the x-axis. So there's x, there's y. And the way I memorize it is because it opens left and right, you go left and right by a. So from the center, which is 0, 0, you go left and right by a. So maybe here's a, and here's negative a. And then you go up and down by b. So then here's b, and here's negative b. And then here's the fun part. Here's where you get to be artistic, is you draw a box. This box has a really cool name, by the way. It's called the fundamental rectangle. Really, really fun. So you draw the box, and then you draw these lines. These are actually asymptotes. These are actually oblique or slant asymptotes, they're called. And I'm going to use a different color here. I'm going to use a light blue. And then the hyperbola has this point here and this point here. And it approaches the asymptotes just like that. It's really, really pretty. Really amazing graph. Really, really fun. You know, conics, this is an example of a conic, are really, really cool. Let's do this one so you see how simple it is to graph based on that. So, and if it doesn't seem simple, no worries. Conics are one of the hardest things that people study, like in a pre-calculus course. It's typically the hardest subject for people to learn. It's this. Okay, this one, the y comes first, so you go up and down by a. See here, x came first, so you go left and right. Or a better way to think about it, opens left and right, go left and right by a. Opens up and down, go up and down by a. So here's a, here's negative a, here's b, here's negative b. Then you draw your box. I really like conics. I actually never learned conics in school. I had to teach myself, and I don't know, I just have a deep appreciation for these creatures. There we go. Really nice. Really, really nice. I love the dots. Makes me feel artistic. So, and you guessed it, this is always on the hyperbola. I always memorize it as a is on the hyperbola. That's what I tell myself. So boom, boom, boom. Oh, I forgot to put my little dot on the A. Boom. Look at that. Beautiful hyperbolas. So there are some other things that go along with these equations. Let's talk about those. So let me, I'm running out of room here, so I don't want to go too far down because I want to show you everything on the screen. So I'm going to put like a little divider here. So over here on the left, there's other things that have names. So you know how I kept saying A is on the hyperbola? Those are called vertices. And that's important to know because sometimes questions will ask you that. So if you're taking a class, sometimes a homework question will say, what are the vertices? So in this case, they're here. So they're on the x-axis. So they're plus or minus a comma 0, right? Because they're on the x-axis. So the x is a or negative a. Let me fix that to make it a little bit easier to read. There we go. All right. And over here, you guessed it, the vertices are going to be the same, right? These two here, except it's written differently. So the vertices are, the ordered pair would be 0 comma plus or minus a. So that would be the equation for the vertices there. All right, very good stuff. Also, the asymptotes have equations. So here, the asymptotes, I'll write it down here. Asymptotes. It's a funny word, right? It's got a P in it. They're y equal plus or minus, and then it's b over a times x. And over here, the asymptotes. So asymptotes. Here, the asymptotes are y equals plus or minus a over b times x. So a over b times x. Good stuff. And then we have one more thing which is really important, which is something that's actually used to define hyperbolas, right? I gave you the equations. I never actually defined a hyperbola. I'll do that in a minute. There's another point which is very important. Let me use a different color. How about orange? It's here, and there's one here as well, these orange points. And there's one here, and there's one here as well. And these are the foci. Okay, these are the foci. So the foci here, the foci would be plus or minus c comma 0. I guess I should give them their names. That'll be c, and that's negative c. Sorry, it's so small. And that's c, and that's negative c. And then here the foci. Here the foci would be 0 plus or minus c. A lot of knowledge, right? A lot of stuff here with this. And in both cases, so I'm going to, I wish I could scroll down a little bit. Let's see. Oh, no, I won't. So in both cases, how about I just use a big color? C squared is equal to a squared plus b squared. So this is the equation that relates a, b, and c for both cases, right? So this applies to both formulas. Easy trick to memorize it. It's a different symbol. Whenever there's a minus, you put a plus here. If there's a plus here and it's an ellipse, you put a minus here. It's the opposite sign to get this formula. Really, really nice. All right, so the other case, I guess, would be when the center is not 0, 0. And basically, so in this case here, it would be x minus h squared over a squared minus y minus k squared over b squared equals 1. Going kind of fast here. And in this case, hk is the center. Okay, hk is the center here. And in this case over here, it'd be very, very similar, except here it's y comes first. So you have to be careful here. It's y minus k squared over a squared minus x minus h squared over b squared equals 1. And I say you have to be careful because notice y goes with the k, x goes with the h, right? Very, very key. Another important thing that, oh, and the center is the same. hk is the center. Good stuff. Another really important thing that's really worth mentioning, and I'm going to write it down because it's that important, is that these little, I don't know what they're called, but they open towards the foci, right? So it always opens towards the foci. Very, very key. This axis here, this piece here, this is called the transverse axis, and over here, this red, just extra fun names, is called the transverse axis. And so the foci always lie there. I always memorize it as, the hyperbola opens towards the foci. I'll write that. Hyperbola opens towards foci. Kind of like a parabola, right? These are not parabolas, by the way, but a parabola behaves the same, right? A parabola opens towards the focus, right? There's only one. Here, the hyperbola opens towards the foci. Really nice. And I guess the asymptote equation changes a little bit. So like in this case here, it would be y equals plus or minus b over a, x minus h plus k. This is actually all from memory, by the way. It's pretty, you learn this stuff. When you learn this stuff, you remember it for a long time. because it's a lot. It's a lot. We haven't even done an example yet. So I really think that might be everything. I think we're ready to go now. We can now maybe do a simple problem. Let's just go ahead and do like a very, very basic one. Let's do x squared over 4 minus y squared over 9 equals 1. And let's graph it and let's find a bunch of stuff. So let's try it. So in this case, in this example, I'll call it an example, the x comes first. So if you remember, that means it opens left and right. So this opens left and right. And the center here is 0, 0, right? There's no h and there's no k. So the center is 0, 0. And if you go back to the equations, and in fact on both, you'll notice that the a is always first in both equations. So a is always the square root of whatever comes first. So it's not like the ellipse. In the ellipse, a is the square root of the bigger number, right? That's key. It's a key memory point, something you want to memorize for ellipses. But here, for hyperbolas, a is just the square root of whatever comes first. What's really important is if the x comes first, it opens left and right. If the y comes first, it opens up and down. Super, super key. Really fun stuff. So here, a is just going to be the square root of 4, which is equal to 2. And b is equal to the square root of 9, which is equal to 3. All right, now we're ready to go. We're ready to graph our wonderful hyperbola. So I'll do it here. Couldn't decide, should I do it over here or should I do it here? I'll do it here. This is x, this is y. All right, this opens left and right, so we go left and right by a. So 1, 2, put a dot. 1, 2, put a dot. And then you go up and down by b. 1, 2, 3, put a dot. 1, 2, 3, put a dot. Connect the dots, and I don't know if you remember the name, but it's called the fundamental rectangle. Maybe because it's fun. Probably not. That's probably not why it's called that, but I always picture the person who named it the fundamental rectangle. It's very interesting name, just kind of fun. Then we draw our asymptotes. There it is. There it is. I feel like an artist when I do this. And then we do our little graph like this, right? Beautiful, because it opens left and right. These are the vertices, these blue dots. Let's go ahead and write those down. So the vertices here would be plus or minus 2 comma 0. The asymptotes would be, so asymptotes would be y equals plus or minus, so it's b over a here, so it'd be 3 over 2 times x. And to find the foci, we have to use our super powerful formula, c squared equals a squared. Remember, it's the opposite sign. So if it's a minus, you put a plus. So plus b squared. So we're looking for c. So let's see, c squared is equal to, well, a here is 2. So this will be 2 squared plus, and then b is 3. So this is 3 squared. So c squared is equal to 4 plus, I'll write it, 4 plus 9. So c squared is equal to 13. So I'll just take the square root, and we'll say it's plus or minus the square root of 13. And that'll be here and here. And so because they're there, right, because they're there, the foci, right, because they're on that transverse, because it opens towards the foci, they're on the x-axis. So that means that it'll be parentheses plus or minus square root of 13 comma 0. The y-coordinate is 0 at both of these points. Let me just emphasize the foci in a different color right here so you see them. Those are the foci. So that would be the foci. So that's the foci, the asymptotes, the vertices. We could find the domain. Let's do that. Why not? So the domain is all of the x values on this graph that lead to y values. So negative infinity all the way to negative 2. And there is a point on the hyperbola at negative 2, so we're going to include it. So bracket, union, and then we're starting back up at 2. And then we're going to infinity. And the range, why not? Let's do it. Just trying to do everything. The range is all the possible y values. Well, this goes down forever and it goes up forever. So that's just going to be negative infinity to infinity. And that would be the range. Really, really interesting stuff. So really nice problem, right? So it's a simple example, but we did everything. And then I guess the other case would be if you did something like this, right? In that case, it would just be different. It would open up and down. and it would be the same process. The foci would change, right? The number would be over here. Another interesting case would be if the center was not 0, 0. Let's go ahead and do 1. Let's go ahead and do 1. And let's do one that's a little bit harder. So let's do y minus 2 squared over 9 plus x minus 1 squared over 4. Now let's do plus 1 squared over 4 equals 1, just to try to make it different. So you see all the possibilities, in one problem, in one video. Okay, so the center here, this is a place where people often mess up. I've seen people mess up here, like on exams and stuff, and I always feel really bad. So remember, x goes with the h, so it's plus, so it's opposite. So it's -1 comma 2, right? Because if you mess this up, everything else is wrong. So it's hk, right? hk. This one opens up and down because the y comes first. So opens up, down. And this, we already have the center. And a is the square root of 9. So a is 3. B is the square root of 4. So b is 2. And now we can graph it. So let's do that. There's the y-axis. There's the x-axis. Hopefully this video is not too long. I have no idea how long it is. I can't see the time. So all right, so the center is -1 comma 2. So from the origin we'll go left 1 and up 2, and I'll put a dot here. Yeah, I'm gonna run out of room, maybe not. So that's gonna be the center of the hyperbola. So because this opens up and down, we're gonna go up and down by 3. So 1, 2, 3. Not really drawn to scale here. I'm doing a bad job of drawing it to scale because I'm running out of room. Then 1, 2, 3. So up and down by 3. Again, not drawn to scale because I was running out of room. And then left and right by 2. So 1, 2, 1, 2. Right? And then we connect the dots. And if you remember the name of this, it's called the fundamental rectangle. And then you, because I didn't draw it to scale, it's going to be very difficult. There we go. I'll put a little curve in my lines, which are supposed to be straight. And it opens up and down. So I'm going to use a different color here. So remember that's there. So it's going to be really wide looking because my picture is a bit off. And there's our beautiful graph. All right. So now we can find other things. So let's see. How about the vertices? So the vertices, a little bit harder now. So that's that's a vertex, and that's a vertex. Okay, so basically we took the center, right, and we went down by 3, right? So so we take the 2 and subtract 3, that'll give you -1. Right? But let's check. That's -1 is the y value. Okay, and the x value is also -1. So -1 is one of the vertices. That's this one here. Right? So it's left 1, down 1. The other vertex would be this one. And so based off the graph, it'd be -1 and then 1, 2, 3, 4, 5. So it should be -1, 5. And based off the center, right, it's -1, comma, and then you add 3 to the y coordinate. So it's -1, 5. Good. I just want to double check. I don't want to mess up. I'm just doing it both graphically and by adding a to the y coordinate. So those are the vertices. I guess we can find the asymptotes now as well. Let's go ahead and do that. Asymptotes. And the formula here was y equals plus or minus a over b parentheses x minus h plus k. Really funky, right? And that's your h and that's your k. So this is y equals plus or minus, a is 3, and this is b is 2, and then it's x minus h, but h is -1, so it's plus 1, and then plus 2, that's your k. I'm going to leave it like this. I'm not going to simplify it. I'm just going to leave it just like that. And if you're doing this for a class, I mean, I don't really know what's expected. Typically, like, I prefer it not simplified, right? That way I don't have to do it. Fun times. What else? Oh, the foci. So we can get those by using this magical equation. C squared equals a squared plus b squared. Remember, it's opposite because, I messed up here. This is a minus. That's a bad mistake. So mistake. It's fixed. Yeah, that's not good. So this is c squared equals a squared plus b squared. So here, what we'll do is we will plug everything in. So a here is going to be 3. So this is 9 plus b is 2, so this will be 4. 2 squared is 4, 3 squared is 9. So c squared is 13. So taking the square root, c is plus or minus the square root of 13. And so here's the tricky part. The foci, you have to think about where they are, right? They're going to be here and here. So you have to add and subtract the square root of 13 to the y-coordinate of your center. So the foci, right, because you have to go up and down from the center. Remember, the hyperbola opens towards the foci. So it'll be negative 1 comma 2 plus or minus the square root of 13. And that would be the foci. And I think I'll stop the video here. That's good enough. Hopefully this has been helpful in some way. Yeah, good luck and take care.